This video is on lesson 6.5, graphing linear inequalities in two variables. So basically that's a fancy way of saying we're graphing a linear inequality. So we've talked before about linear equations like y equals 3x plus 8 or y equals 2 halves or 2/5 x minus 11. And we've talked about how to graph those equations and what the slope means, what the y-intercept is, and all of those good things. So all we're doing here is we're just, again, adding to this with the inequalities, similar to what we have been doing all chapter. So if you look, there are four basic steps here. First of all, we're going to change the inequality sign into an equation. So we're going to graph this inequality as if it were an equation, which we know how to do, and you have done multiple times. So you're first going to pretend like it's an equation. Then you're going to graph it as if it were an equation. Once it's graphed, once you have your dots, your little points down on the graph, that's when you're going to consider, is it a dotted line or a solid line? So just like before when we had just an inequality, when we graph them on the number line, if it was less than or greater than, so without the equal sign, then we had an open circle. If it had the equal sign, then we had a closed dot. Well, very similar here, we are going to make a dotted line if it's greater than or less than to say basically the numbers that are on this line cannot be included, but anything on either side will be included. So similar to when we had just a number line and we had an open circle versus a closed dot. And then we're going to check a point that's not on the line to check and see which side of that graph we have to color. So it's really not that difficult. So let's look at this first example together. Here I have an example for you. Y is greater than or equal to 2/3 x plus 1. All right, so you can see here on my graph, I've already graphed that for you. So I took my 1, which is my y-intercept, and I plotted that point right here. Then I took my slope of 2/3 and I counted rise 2, run 3, rise 2, run 3. That's the same thing as dropping 2 and moving to the left 3. Drop 2 and go left 3. So now I need to consider, is it a dotted line or is it a solid line? So I look at my inequality symbol. It's greater than or equal to. So that means it's going to be a solid line because that equal to component. So now I'm going to take my ruler and I'm going to draw my line. Now, if it were just greater than, I would make a dotted line here instead of that solid line. So you could either go back and erase it so it has dots on it or however you want to do it, as long as it's not solid. Okay, so now I have my line. So now I'm on step 4, check a point not on the line. Well, the easiest point we've talked about all year long about working with is 0. So if I use this ordered pair 0, 0, that's right there, and I plug it into this equation up here. So I'm going to have 0 is greater than or equal to 2/3 times 0 plus 1. So 0 is greater than or equal, 2/3 times 0 is 0, 0 plus 1 is 1. Is 0 greater than or equal to 1? Well, no, it's not. 0 is less than 1. So this is false. This statement is not true. So that means this ordered pair right here, 0, 0, is not a solution. So I cannot include that number, which means I don't want to include anything on this side of the line. So I'm going to shade up here instead. And I shade above that line. Let's look at another ordered pair just so you understand that it's not a solution here. Let's choose the ordered pair positive 2, negative 3. Okay, that's the ordered pair 2, negative 3. So I'm going to plug that into my equation. So I'm going to use negative 3 for y is greater than or equal to 2/3 times 2 plus 1. 2/3 times 2 is 4 1/3 plus 1. Well, already I can see negative 3 greater than or equal to a positive number. That can't be true. Negatives can never be bigger, so this number is not a solution. So it should not be shaded in, which indeed it's not. Let's look over here at this. Let's find a shaded point here. Let's use 0 for x and 1, 2, 3, 4 for y. So we'll choose that point up here. So now this ordered pair is 0, 4. So I'm going to plug that in. I'm going to slide this to the right here a little bit. So I'm going to have 4 is greater than or equal to 2/3 times 0 plus 1. 2/3 times 0 is 0, so 4 is greater than or equal to 1. Well, that's true. 4 is greater than 1, and that ordered pair that gave me that true statement is shaded in. So that's how I know which side of my line to shade based on my equation. All right, I'm going to give you this last problem to do on your own. The inequality is y is less than 1/2 x minus 2. So first step, pretend it's an equation. Use 1/2 as your slope, -2 as your y-intercept, and graph that. Then look at the inequality sign and determine, is it a dotted line or a solid line? After you make that determination, use the ordered pair 0, 0, unless the line goes through 0, 0. This one it does not, so then check that 0, 0 and check and see if it falls, if it's a true statement or not, and then shade accordingly. The only time you can't use 0, 0 is if the line goes directly through the origin and through that ordered pair. You never want to use a point that's on the line. You always want to choose something off the line. Okay, have that done for class, and we will discuss it then. Have a good night.